Hey, what's going on, guys? Let's see how we can do this problem right here. So we have this system right here that's compressed like this, and then they have given the initial pressure and final pressure. Here the pressures are same. It means it's an isobaric process. Isobaric process. So whenever we have pressure constant, that's an isobaric process, right? And here we have volume that is different, 15 liter to 2 liter. And let's see how we can calculate all of these values. So first thing we can do is we can draw the PV diagram. So let's draw the PV diagram, right? So this is going to be P and this is going to be the volume. And here we know that pressure is constant, so this is going to be a straight line like this. So this is going to be 1.5 atm right here. And also they have given the initial volume and final volume. So this is going from 15 liter to 2 liter. So it's starting from here, 15 liter, right? So this is going in this direction, 15 liter to 2 liter. So this is going to be something like this, right? So this is going to be our PV diagram. So from this one, let's see how we can figure out these T1, T2, Q, W, and delta Q. So first, let's start with T1. Here they have given n is equal to 1 mole. And T1, they are asking for T1, so we can use PV is equal to nRT, right? T1, V1. So here we have pressure 1, we already know, volume 1, we already know, and N is provided right here. So from this one we can find the T1. So T1 is going to be equal to P1 V1 over N times R. So here we have 1.5 atm P1, 1.5 atm times V1 is provided 15 liter, right? And N is provided 1 mole, and R is a gas constant that's going to be 8.315 joule per Kelvin mole, right? So this is going to be the value. And if you look at the top part, we have atm and liter, so we have to convert this one into joule. So that if we convert that one into joule, then only that will cancel this joule right here. So we have to convert this one into joule, so we have to multiply this one by 101.3 joule per atm liter. So that's how we convert atm liter into joule. So here from this one we can calculate this temperature, and if you plug all these values in calculator, you will get 274 Kelvin, right? So we have solved for T1. T2, it's going to be the same thing. We simply have to write this one in terms of P2, V2 and T2. So this is going to be P2 V2 is equal to NR T2. Therefore T2 is going to be equal to P2 V2 divided by NR. So here also same thing, P2 is going to be what, 1.5 atm, 1.5 atm times V2 is 2 liter. To convert this one into joule, we have to multiply by 101.3 joule per atm liter. Then we have N, that is 1 mole. Then we have R, gas constant, that is 8.315 joule per Kelvin mole, right? And if you calculate this value, that's gonna give you 36.5 Kelvin. So we have answer for, we have done this one. So let's see what we can find next. So for the work, there are two things we can do. We can find the area of this graph, because whenever we have PV diagram, whatever the area below the diagram is going to give us the work. Also, since we have isobaric process, we can use this formula. W is equal to P delta V. So if you use this one, this is going to be P is 1.5 atm delta V is going to be final minus initial. So here final is 2 liter minus 15 liter. The answer is definitely going to be negative because we already know that we are compressing this gas. So whenever work done to the system is always going to be negative, right? If the gas expands, it's done by the system, then it's positive. Here we are compressing, so it's going to be negative. So here we have ATM liter. So to convert this one into joule, we have to multiply by 101.3 joule per ATM liter. And if you calculate this value, you will get negative 1975 joule. So that's going to be the work. So let's see. So we have found the work. Let's see how we can find the Q. To find the Q, you can use NCP delta T, or you can find the delta U, that's NCV delta T. So delta U is equal to NCV delta T. So here somebody may say, since this is an isobaric process, why are you using NCV? You are supposed to use CP, right? Because that's not the case, because that's for Q. If it's Q, you can use NCP, right? It changes for Q. Like if it's constant pressure, you use NCP delta T for Q. And if it's constant volume, you use NCV delta T for Q. But for delta U, it's also always going to be NCV delta T. So we don't change anything right here. So here we are going to have 1 mole times, so let's see, so N and CV. So this is an diatomic molecule, right? So the CV is going to be, for a monoatomic is 3 by 2, for a diatomic is going to be 5 by 2 R. So 3 by 2 R, 5 by 2 R, 7 by 2 R. So it goes like this. This is a diatomic, this is a diatomic molecule, so we're going to use 5 by 2 R. So this is going to be, let's use the unit. So this is 1 mole times CV is going to be 5 by 2 R, right? 5 by 2 R times R, we can plug the R straightly maybe. Let's write this one somewhere right here. CV is equal to 5 by 2 R. We can plug the R, that is 8.315 joule per Kelvin mole times the change in temperature. That's what we are, change in temperature. Do we have the temperature change? Yeah, we calculated that already, right? 360. So final temperature is 36.5 and initial is 274. So we can simply subtract that. So that's going to be 36.5 Kelvin minus 274 Kelvin. And if you calculate this value, that's going to give you negative 8.35. So this is going to be what? Yeah, negative 4,930. So 49375. So that's what we get. So let's verify this one. 4937. Okay, this is actually 4937 joule. Right, so this is the value we get. And then to calculate, now we have delta U. You can calculate Q using NCP delta T, or you can use the simple formula that delta G is equal to Q minus W. That is much easier rather than plugging all the values and calculating, right? So here we can rearrange this one to find the Q. Q is equal to delta G plus W, and here we know delta G is negative 4937 plus del W we calculated right here. Yeah, so that's going to be negative 1975, and if you add them together, that's going to give you 6912 joule. So that's going to be the answer. So let's write it. Since it's not clear right here, I write this one right here, 6912 joule. So that's negative, because we are adding negative values, right? So this is negative, and that's going to be the final answer. And that's how we do this kind of problems. See you next time.